Alright, so we'll move on to quiz 2, right? So question 11 for this video. So what this question is, it's basically the idea of cross-validation, right? Cross-validation. And we want to introduce a generalized version where we kind of use an average of the diagonal terms of this matrix here instead of individually finding them out, subbing in one at a time, because this is more efficient, right? And now we want to show that this is actually, in fact, well, these two are pretty much the same when n is a very large sample. Right. So, to show this, you should pretty much just focus on what p bar is. We should find what p bar is first, because, well, that's pretty much the only kind of unknown for now. Because if you focus on these functions here, right? This one's sigma hat. You can see that this thing over here is pretty much this LT thing, right? If you recall from notes, it's just a loss function of your estimator, or your in-sample risk, I should say, right? And the sigma squared thing is similar to this. It's just that the diagonal, the new denominator is n minus p instead. So sigma hat squared equals to summation, 1 over n minus p, sum I 1 to n, yi minus xi transpose b squared, right? Because it's the average of, well, it's a average of the residual errors, right? And the number of terms influences the what do you call it? Degrees of freedom. So we should find what p bar is first, right? Because you can see that this top part is pretty much irrelevant, or it's very taken care of in these two terms. So somehow the p bar transforms, right? So we will first find p bar, which is defined as this, right? So since p bar involves the this trace of this matrix, you should find what this trace is, obviously, right? Now, the first thing you should note, and as you kind of see here, the rank of x is p, right? So that means the, well, amount of leading columns it has is p leading columns. So essentially, since you see this rank thing and you see this x, this pseudo inverse shenanigans, the first thing that should come to your mind is SVD, right? Because that makes things a lot easier. So using SVD on x, we have x equals to, I'll use A in this case, A sigma B transpose, where rank of sigma equals to P, right? Because this is the same reasoning as quiz 1, question 10, right? The ranks are the same as the full matrix. Diagonal. So we want to find a trace. So we want to focus this thing, right? So we want to find the trace of x plus. So we kind of just sub things in now, right? So trace. So you just sub in b, or x, I mean, b transpose. Right, it's x, the pseudo inverse of x in SVD form is really easy to find. Just b plus a transpose. Since this is, what do you call it? I forget what it's called. It's orthonormal, right? So you can just get rid of it. That's fine. Sigma plus a transpose. Now here you need to use one of the properties of the trace. So the property I'm going to use is the fact that the trace of, say, xy is actually the same as the trace of yx. So you can swap the order of your multiplication of matrices. Doesn't really matter, and you'll get the same trace. This isn't too difficult to prove. I'll leave it for you guys. It's literally just kind of swapping the order. Like, you just represent it as a summation on both sides. You just middle summation shenanigans, and you just swap the order of it, and you should get the answer. Right? So I'm going to use that here. Yeah. So this leads to the fact that this is just trace sigma plus A transpose A, and A transpose A is just the identity matrix. So you just end with this. Right. As you can see, you have the diagonal matrix and the pseudo-inverse diagonal matrix. Right. Since this diagonal matrix is of rank P, essentially what happens is trace just becomes a summation of I1 to P of, say, sigma I over sigma II. Right? The reason why the other terms disappear because they're 0, and we're talking about the trace terms. Right? So the P plus 1 to n terms are all 0. Right? And this is just equal to P. Right? So you can see that's where kind of this P thing comes in to play. You can see what the number of the rank comes into play here. It's because the trace of this thing is actually equal to P. So, subbing things in, we have that. So we know that. So, P bar is equal to P on N because it's defined as, if I can see over here, 1 on N of the trace. Right? We just found a trace, so we just divide by N. So that means the general cross validation is equal to 1 on N, this thingamajiggy, yi minus xi bar squared times by 1 minus P on N minus 2, right, because it's in the denominator. Right. Now what I'm going to do is, if you look at the hint, right, they say use the binomial series. This isn't, so I'm going to somehow use this thing over here, right? Because as I stated earlier, this factor kind of already appears in the two terms above, right? It's already involved in them, so you don't need to change it per se, because you can just factorize it out. The big change is to do with this underlined green thing. And to do that, since it's a negative power, and we want to use the binomial series, all you do is make it non-negative. So you just flip this thing inside as well. So what I mean by this is you just go 1 on N. I'll just draw the box to represent this box thing. And what you do is, so rather than keep the power -1 outside, you do, so this would be, okay, I'll just kind of simplify that first. That will just be N minus P of N. Just factorize it. So this will be N, N over N minus P to square, right? Just bring the -1 inside. So now you have a positive binomial function, right? And since you want it in binomial form, you're obviously going to use, we're going to split it such that one is as a 1 and a P, oh no, as a 1 plus some term. So this equals to 1 on N square shenanigans times by 1 plus P over N minus P squared. Right, and if you were to expand this thing over here, so you'll get close to 1 on N squared thing, because this thing appears in both terms anyway, 1 plus 2 P over N minus P plus P squared over N minus P all squared. Right. So now, if you were to kind of group things up now, right? So you will end up with 1 on N. I'll actually write out the box thing again. N y I minus x I transpose b squared plus 2 P over N times 1 over N minus P. This thing is jiggy again. Y minus xi transpose b squared plus p squared over n minus p squared n and this thing over here. I'll just write box again. Right. Now if you look at this first term over here, this is literally just your L, like from your lecture notes, this is your LGT, right? G in this case is just your linear function, right? They just choose the general function for some reason in the solutions. G. And if you look at this second part over here, I'll choose a different color, green. This thing over here, this is just your sigma hat squared, right? This is your estimated standard error, right? Because you just divide it by the number of mu n minus the new degrees of freedom, which is your rank of x. Alright. So you can see that from that, it's pretty much just equal to L tilde, G tilde, or I should write approximate, plus 2p on n, that's the first part, times by sigma hat squared. Right? Pretty much that, because the very last part, because if you imagine as n goes to infinity, this thing over here is basically insignificant relative to everything else, because everything else over here, right? So you kind of just look at this, they're all powered over n, whereas this thing over here would be powered to n squared, right? So compared to everything else, it'll be very small, right? This n minus p thing goes into this thing. Oh wait, no, let me rephrase that, right? Because this n thing over here contributes to this whole thing, right? Because in this 2p over n, this is only power 1, whereas if you were to kind of look at this, it will be power 2, so power 2 will be insignificant relative to this thing, right? So that's why you end up this as n goes to infinity. Plus, I kind of just write it out, I guess. P squared times by L tilde G tilde, which goes to 0 faster, because this is n squared. And so it pretty much disappears compared to everything else. Alright, so that's pretty much the main intent for this question, right? It's pretty much, it's not too bad, this question, right? It looks a little concerning because you see this L shenanigans, this loss thing, and like in the question, right? It's pretty much just, well, you just kind of follow what they tell you to do. You have to find the average, obviously, because that's the thing you're subbing in this formula. Right, this P bar thing. And so to do that, you need to know the trace tricks, right? The trace tricks are, you can just rearrange the multiplications and you'll get the same trace answer, right? And the next trick is that since this thing's in a denominator, the question says to use the binomial series. So you want it to be positive, right? So that way you can actually use the binomial formula properly. You just bring the power inside, the negative power inside, and then from there you just work out everything else. Right, so this thing is your answer. Right, and that's pretty much all for this question.